Welcome to EduPorm EdTech. You're watching expert chemistry lectures with Abhinav Gaur. Today in this video, we will study about two reasons behind defect, in which the first reason is occupation of interstitial site. Okay, we will study the interstitial defect, and then we study the defect due to vacancy. So we will study the vacancy defect. So first of all, there are two types of site in a crystal. First is the lattice site. First site is the lattice site. Lattice site is the position where the lattice point should be present. Okay, it is the position in a crystal where lattice point should be present. For example, if I talk about body-centered crystal, so it means that a body-centered crystal will consist of one lattice point present at each corner. 1, 2, 3, 4, 5, 6, 7, 8, and one lattice point present at the center of the body. So this is the lattice site of the crystal which should be present at the body, and this is the lattice site of lattice point which will be present on the edge or on the corner. Okay, so the point where by default the lattice point, that means the atom, the molecule, the ion should be present, is called as the lattice site. And there is one more site which is called as the interstitial, the interstitial site. Now what is this interstitial site? Interstitial site is a site where sometimes the lattice point is present. Okay, where sometimes the lattice point is present, and we define it as the site other than lattice site. Okay, this is the site other than lattice site in a crystal geometry. Okay, so what happens, let me tell you by means of an example. Let's say this is the crystal geometry. We have a cation, anion, cation, anion. We have a anion, cation, anion, cation. We have a cation, anion, cation, anion. Now all these are the lattice sites where the lattice points should be present. But let's say that here the lattice point is not present, but this lattice point is shifted to this position. Okay, so the lattice point that should be present at the lattice site is not present at the lattice site. It is not present at the lattice site, but it is present on site other than lattice site within the crystal, called as the interstitial site. Okay, so when any cation or sometimes anion is not present at lattice site, but it is present on the interstitial site within the crystal geometry, then the defect is said to be interstitial defect. Okay, and in this defect, as there is no loss of mass, so the density remain mostly the same. Okay, so the density remain same. So after this defect, there will be negligible effect on the density of the crystal. Now we have vacancy defect. Okay, what happens in the vacancy defect is, let's say we have another example, and a cation, anion, cation, anion, cation. We have anion, cation, anion, cation, anion. Then again cation, anion, cation, anion, and cation. Now let's say one cation is completely missing from the lattice site. Okay, it is completely missing from the lattice site as it leaves the system. Sometimes cation can be missing, sometimes anion can be missing, sometimes both anion and cation can be missing in equal number or unequal in number. We will discuss all this later, but in case of vacancy defect, a cation or an anion or both are completely missing from the system. Okay, so they leave the crystal geometry, and as they are leaving crystal geometry, the defect will produce a vacancy, so the defect is called as vacancy defect. And as we can see that there is loss of mass, okay, there is loss of mass. So as density is equal to mass upon volume, that means density is directly proportional to the mass, and as there is loss of mass, so the density will decrease because of the vacancy defect. So this is the main concept of interstitial defect and vacancy defect. Please watch the next lecture of the series to know more about defects. Thank you.